All right, in this video, we are going to look at differentiating equations with respect to time or with respect to t. And it'll lead in, this will be a short little lesson on differentiating with respect to time because this will lead into something called related rate problems. So let's just start with a function, something like this. And I believe we looked at a function similar when we talked about implicit differentiation. So say it says x squared plus y squared equals 36. All right. If I wanted to differentiate that with respect to x, okay, well, the derivative of x squared would be 2x, and then I could write times the derivative of x with respect to x. Well, that's just 1. Okay, so that's not going to show up. That differential won't show up. Okay, I'll leave it there, actually. Just let me leave that there for now. I'll show you what we'd get for an answer. Plus, the derivative of y squared with respect to x would be 2 times y times the derivative of y with respect to x. And the derivative of a constant, 36, with respect to anything would be 0. So long and short, we would have written this as 2x plus 2y times dy over dx equals 0. Now, if I were to solve for dy over dx, all right, I would subtract 2x from both sides, and then I divide both sides by 2y. And I'd end up with negative x over y for my dy over dx. It didn't say to solve, okay, so all I really had to do was this line right here. Now, we could have easily have done that question differently if they had asked me to differentiate with respect to y. It would look like this. The derivative of x squared with respect to y would be 2x times the derivative of x with respect to y. The derivative of y squared would be 2y times the derivative of y with respect to y. Now in this case, this differential doesn't show up. This would still be 0, and I would be left with 2x times dx over dy plus 2y equals 0. Okay, so instead of solving for dy over dx, in this one I'd solve for dx over dy. I'm not going to do that because it didn't ask me to. What if it says to differentiate with respect to time? Okay, and this is kind of what's going to lead into our related rate problems. This will be the key to solving a related rate problem. So let's look at that same equation. This time, let's differentiate with respect to time. So the derivative of x squared becomes 2x times this differential dx over dt, plus the derivative of y squared would be 2y times the derivative of y with respect to time. And again, the derivative of a constant with respect to whatever is always 0. Okay, and that's what it would be. Okay, this right here, differentiating with respect to time, is going to lead into this. Now this will be a lesson for the next video. We'll start exploring related rate problems. But in a related rate problem, you're given the rate of change of one quantity, and we're asked to find the rate of change of another quantity. The two quantities will be related by a specific formula, so some common ones you'll see are like the area of a circle or the volume of a cone or Pythagorean theorem. All right, we'll look at various formulas or various related rate problems, but that's a lesson for the next video. To do it, you find the formula that relates the two quantities or three quantities that you're working with, and you differentiate both sides with respect to time, so like I just did. All right, here are a couple problems. It says if x times y squared equals 12, and you know dy over dt equals 6, they want me to find dx over dt when y equals 2. Okay, I want to differentiate with respect to time. So I have this equation, xy squared equals 12. If I differentiate that with respect to time, think of this as x times y squared, all right? So it's a product rule. I would do the derivative of the first. Now remember, the derivative of x with respect to x would be 1, but the derivative of x with respect to time is going to be this differential, dx over dt. So that's the derivative of the first times the second, plus the first times the derivative of the second. Well, the derivative of y squared would be 2 times y times the derivative of y with respect to time. And it's going to equal 0. Now you'll notice that they've given me this, right, dy over dt. That's going to be a 6. They're asking me to find this, and they're telling me that y is 2. All right, so I'm going to replace the y with a 2. What's the problem? Well, I don't have this guy right here. Well, in order to do that, I can find x. If I know the initial or the original equation is x equals y squared, x times y squared equals 12, sorry, and I know that y is 2. All right, I just fill a 2 in there, and I'm going to solve. This would say 4x equals 12. X is going to equal 3. Now, I'm just going to pump all this information in there. And I will solve for dx over dt. So dx over dt is what I'm looking for. Y we know is 2. So there was a y here, and I square it, and a y here. And I know that x is 3. I just found that. So this would be a 3. And dy over dt is 6. When I work this out, I get 4 times dx over dt equal to, or sorry, plus 6 times 6 is 36 times 2 is 72 equals 0. I would get 4 dx over dt equal to negative 72. Divide both sides by 4. And I would get dx over dt equal to negative 18. Okay? So there it is. Have a look. A lot of people like to do this step first. Okay? They usually only give you x or y, so you have to find the other and then differentiate with respect to time. So remember again, the derivative of x with respect to time is dx over dt. The derivative of y with respect to time is dy over dt. Okay? Here's one you can try. Okay? Try this on your own. Pause the video. Give it a shot. All right. And then start it back up, crank it up, and see if you got the right answer. All right. So differentiate with respect to time. The derivative of x cubed would be 3x squared times the derivative of x with respect to time, plus the derivative of y cubed is 3y squared times the derivative of y with respect to time, and it equals 0, the derivative of a constant. Okay, I am looking for, so they tell me dx over dt. I know that this is going to be a 4. They're asking me to solve for this one this time, dy over dt. All right, x is 2. I need to find y. All right. Well, to find y, I'll take that initial condition and I'll solve. I'm going to fill a 2 in here. I get 2 cubed is 8, plus y cubed equals 9. Y cubed is going to equal 1. The cubed root of that would also be 1. Okay, so I just subtracted 8 from both sides. So if y is 1, I'll fill that in here. So let's see what I have for values. It's going to be 3 times x squared times dx over dt. That's what I'm looking for. X we know is 2 plus 3 times y squared. Well, y I just found to be 1. And dy over dt, that's what I'm looking for. Sorry, that's the one I'm looking for. So this guy right here is known, it's given. That is 4. So if it all equals 0, we can solve this. I have everything. I'm looking for this one unknown. So this is 3 times 4 times 4. That's 48. Okay, this is 3 times 1 times dy over dt. 3 times the derivative of y with respect to time is going to equal negative 48. And when you divide both sides by 3, we end up with negative 16. Okay? There's a worksheet for you to go to work on now, but those are examples of differentiating with respect to time. And that's what's coming down the pipe when we look at our related rate problem.